100%. Now it's going to walk off the end. But look at it go.
And they do make servos that are faster than these, so really Will could take his design.
Well, that's my one robot. This, actually that was my first one, but it was, the middle legs didn't swing back and forth. They just rotated, and it had a funny gait. It would move forward, and he'd sit there and wiggle its legs and get its legs back in the front and go forward. And I didn't like that, so I spent lots of time modifying that. It's got two switches on it. One of them turns the power off to the servos. The other one turns the power off to the microprocessor. Same as this one. Now this is my first attempt at building a four-legged one. Four-legged is a little harder than six legs because it tends to be less stable. You've got to have, since it's not dynamically stable, you've got to have at least three legs on the floor at any one time, and so you can only lift one leg at a time. You got to make sure that the weight is balanced. You'll notice that I don't have any knees on this robot. It's just got stiff legs. The reason for that is I was looking at pictures of animals that were walking, and I noticed that as long as the legs had load on them, they were essentially straight. And the problem is that the leg pivots back and forth, the hip goes up and down. And so to accomplish that, my legs go like this, and that's the way it lifts the leg off. So on each end, it does that. Now to make it go in a circle, or make it turn, I've mounted each servo on a vertical pivot, and they pivot so they almost act like car wheels. They actually turn. And so I think if I set it here and turn it on, it'll walk more or less. It goes in about a 4-foot circle, if I remember right. It's awful shaky. I'm not exactly sure. All the mechanics are a little bit springy. It has a Omega 16 on it. Most of the code is written in the interrupt routine. The servos require a pulse 50 times a second. So every 50 times a second, it calculates a new position for each one of the legs.
Rotation, is that
Yes,
right?
it's monitoring the wheel, so it knows how far it's gone.
It's doing its turn, and it's on the table there.
Yeah, okay, there it made its U-turn. So it'll come straight, and when it got back to the starting line, it could have gone straight. It would have stopped after it stopped.
We have contests twice a year. Usually have 3 or 4 events in each contest. They're usually for the smaller robots, although we have more interest in the outdoor robots. They can go hundreds of yards and find certain targets and things like that, and then come back or just reach a target. Different levels of skill are involved. The contest he was talking about called Quick Trip, which is start here, go down there, come back here. Now it sounds simple, and in theory it should be simple, but you would be surprised how many robots don't get across the starting line. Because, they'll be like, okay, all right, all these blinking lights, so it's probably going to work. Like, okay, that one, and then that one, and then that one, and then like a 5-minute limit, and then 5 minutes is kind of like, hang on, we're going to have to call time on you. Okay, next, and it just doesn't work, because our motto is, it worked at home. But it does balance.
It's balancing 50 times a second. It's evaluating its position and its speed. If it starts to fall one direction, it'll quickly speed up in that direction to regain its center of gravity.
Will it protect the edge of the table?
It will by falling off.
Only on the its acceleration downwards greatly increases.